which is presented by Taryn Heilman from Galvanize. A little bit about Taryn while she gets ready to join our virtual stage. Taryn's academic background is in math and astrophysics. She spent a few years between undergrad and grad school teaching high school and college level math courses as well as doing research. After graduate school, Taryn went into the data industry, beginning with a data scientist position at Oracle. She is a passionate teacher with a wealth of industry relevant knowledge. So Taryn will be talking today about strategies to measure value from your data teams and projects. And with that, Taryn, I'm going to toss the mic over to you to kick off today's keynote.
Great. Thanks, Charlene. All right, let me remember how to share screen on Zoom here. Share screen.
I can let you know, Taryn, when, it is up, and I think we just need it in presentation mode. Thank you.
And that should be it. Okay.
That's right.
Excellent. Hi, everybody. Thanks for that introduction. So I'm going to be talking today about ways that you can measure value from your data projects as well as from your data teams, and really just about setting an experimental data-driven mindset as you think about what data teams are doing with their time. And this is a little bit of a self-serving talk, and you'll kind of see maybe why that is as I go on here. Charlene already gave you my background, so I won't linger too long on that. So I am currently the acting head of data science for our Galvanize enterprise department. So we go into big enterprise companies and mid-sized enterprise companies and provide upskilling for their employees in really all areas. Like we teach executives, we teach data literacy to really the general population of the company, and we also provide upskilling to data teams, you know, getting them more on modern technologies like programming, version control, etc. So first I'm going to talk, just kind of set the stage on AI and data science, where it is today by the numbers, and hopefully motivate you to why measurement and the scientific mindset is so important. And then we're going to talk about the maybe easier thing, which is calculating the value of data projects, and then the possibly harder thing, which is calculating the value of your data teams, value provided by your data teams, obviously. Data teams are usually made up of humans, and humans are all intrinsically valuable in ways that we can't calculate, but strictly just going to talk about the value that they generate as a team. Okay, so about AI and measuring things. So we all know the data science and AI is huge. That's why everybody's here. Just some numbers, some stats for you. By 2030, simulations indicate that 70% of us will have adopted AI in some way. And 91% of organizations have adopted or plan to adopt a digital-first business strategy. So this is huge. Companies, big, small, tech companies, retail, manufacturing, everybody is investing in some sort of AI, you know, and we can use AI in a number of ways. Pretty much every business line has something that they do that could be aided by including some AI. But there are also some sobering statistics here. 85% of data science projects fail. This is not always a bad thing. Experimentation is part of science, but chances are that that number is still higher than it needs to be. Only 4% of companies have succeeded in deploying machine learning models into production, which is generally the benchmark for what is required to actually make those things be useful. And 76% of CEOs are concerned about the lack of digital skills in their workforce. So there is a definite mismatch between where businesses would like their workforce to be and where they actually are. So I'm gonna do some motivation here, and we're gonna do a thought experiment about goals and measurement. There may be some people in the room who empathize with this. In this hypothetical, we have two people who've gained a little bit of weight during the COVID lockdowns. And so person A has this observation. I've gained some weight. I don't really like the way I look anymore. So I'm going to eat better and I'm going to lose the weight. And person B has maybe a bit more of a scientific approach, and they say, I know that I've gained exactly 10 pounds during the pandemic. So what I'm going to do is I'm going to maintain a 500 calorie deficit every day. I'm going to do cardio 3 times a week. And I will know that I have succeeded in this weight loss plan once my pre-pandemic genes fit again. So which person do we think is more likely to succeed? Person A, person B? All of the research shows us it's person B. They've done a couple of things better than person A here. They have measured the problem. They know the scale of the problem. It's not like, I got a little pandemic fluff. It's 10 pounds. I know I have gained 10 pounds. They have a pretty distinct plan that is testable and measurable to solve the problem. And they have an idea of what success looks like. And so this is what we should be doing for every data project that we set out to do. And this is something that I see in a lot of our clients that is not generally the case. A lot of times it's something that, oh, this sounds good, or some other company is doing this, so maybe we should try it, right? What actually should be happening is that all projects that are done should come with a testable hypothesis. Right? You should have some idea of, if this project works, success will look like this, and I will know that I have succeeded if this happens. Here's how I will measure whether or not this project works. Sometimes this is really intuitive. One example is, let's say that you're trying to send out like a coupon campaign to stop customers from churning. That's something that, either they stay with the company or they don't. It's pretty easy to measure. There's not going to be a lot of quibbling back and forth as to whether your project was a success. Other things we do are a lot more complicated, a lot more nuanced. The success metric might take some haggling to figure out what it is. General guidelines: make sure you leverage domain knowledge as you're doing this. Determining a success criteria should not be solely the object of the data team. This should be, all the stakeholders should be involved in this. And then every data project is going to be an experiment. Not everything is going to work or bring value, and you should have ways to pretty quickly measure whether it's bringing value and have a plan to call it if it's not. You should be using a workflow with everything so that you have stakeholder feedback at various points throughout this project. All experiments must be repeatable, which means your data scientists need to be working, they need to be using version control, they need to be documenting the steps to their work so that somebody else could go out and try this and see if it still works. And then again, success, failure conditions, you have to have that testable hypothesis and know what it is that you're trying to find or measure ahead of time. Just some quick terminology on scientific thought. Degree of belief. And this is how we feel about a hypothesis, right? Some things we may have no idea going into it whether or not something's going to work. Other things you may have a pretty good idea of, yeah, if I give customers this coupon, past experience tells me that we will get more business out of this. Your hypothesis is is the guess that you make based on your prior knowledge. This is the thing that you're trying to prove. And a scientific theory is an in-depth explanation of that observed phenomenon. This comes up in papers a lot. People misuse the word theory a lot. If something is called a theory, it actually means that there is a huge body of evidence to support it. It's not just something that somebody came up with. Scientific theories are testable. They make falsifiable predictions. So each project that you go into should invoke the scientific method. So formulate your question. Does a COVID-19 policy of mandatory masks affect the number of hospitalizations? Right? You should be able to count the number of hospitalizations before and after and know whether this policy works. You can create this hypothesis that says, yes, I do think that it will affect the rate of hospitalizations. Even better if you can guess how much it will affect and decide, okay, if it affects it this much, then it's a success. Right? So this noticeable drop is it's kind of weak language. We could make that a little stronger. All right, and then you conduct an experiment, you impose a mask mandate, you draw some data, and then draw a conclusion. Mask mandates do or do not affect the hospitalizations. Okay, so now that we kind of are in this experimental scientific mindset, I'm going to transition to talking about value from data projects. So first of all, like what are our data projects? Like what are these end results here? So our data talent, our analysts, data scientists, data engineers, machine learning scientists, and engineers, uh, they're putting together some sort of product for you. Ideally, this is deployed in a way that as many people can see and interact with it as possible. So this could be a web application, it could be a dashboard, it could be some sort of Dockerized application. They could have an API that you're interacting with if the end customer is also a programmer. And then you're trying to calculate some sort of return on investment from those things. And that is not always very straightforward to do. One thing that I've noticed that executives really like is that they want return on investment to be in dollars, always. And you can usually get some sort of dollar return on investment, but a lot of times it's a very convoluted complication. And it is very often the case that what AI does is save you time and saves you person hours. And that is, a little bit more complex to turn that into dollars, but it's not impossible. So how you calculate that ROI depends on what type of business opportunity you're addressing in your data project. So there are a couple of things that you could do. You could have a new opportunity. And a lot that you see here would be something like software as a service, right? You are entering a new market, you're building a new product that you're going to sell. This one is generally the easiest kind of opportunity to get a dollar sign ROI out of. Your next thing that you'll see, and quite frankly, the most common, is an improved opportunity. And this is where your data project is improving an existing process or product. So you might be building a recommendation engine to recommend things to customers instead of just recommending items that were popular, right? You're trying to make recommendations that are more customized. Some of the most successful companies in the world, think Netflix, think Amazon, have the best recommendation engines in the world working for them. And they make crazy amounts of money by doing just this. The example I brought up earlier, where you might be trying to stop customer churn. This is an improved opportunity, right? We're just trying to prevent ourselves from losing customers. Lastly, there's automated opportunities, and this is where you automate away tasks that are taking human labor. One of the most common things here is with text processing and speech processing. So if you have ever called a customer service line and you have spoken to a chatbot for the first few stages, this is an automated machine learning project. Same thing if you've talked to a customer service agent online. Usually you're talking to a computer for the first few stages. Quite often, incident reports that are filed at large companies, those are classified using natural language processing. They are not always read by humans. Resumes are not always read by humans. Right? This is all automation. So in terms of measuring the ROI from these things, your new opportunities are usually going to be measured in money, right? If you're going out and selling a machine learning product to somebody, you're usually paying you money to do that. So it's very straightforward. How much did it cost us to develop it? How much will it cost us to maintain it? And then how much are we going to sell it for? Now, your improved opportunities, depending on what you're doing, could be measured in dollars, right? Maybe you're saving yourself from losing customers and you know how much revenue you take in from an average customer, and you could measure that in dollars. You could also measure it in person hours. Maybe you're improving a process so that it takes less time. So you've saved yourself time, and your people, you can either have less people working on something, or you can have people working on things that are higher value, harder, can't be done by a computer. Automated opportunities, if you're automating something, you are saving person hours. Plain and simple. When you're trying to measure these things, you want to control your variability as much as possible. Remember, we're trying to conduct things as experiments. So maybe you measure revenue versus purchases. Maybe you measure customers versus revenue. Sometimes it's hard to get dollar signs out of this. Sometimes it's a really convoluted process. And so you know that maybe you're testing, does my new web page get more traffic? It might be hard to say if your web page gives you more revenue. That might be a really complicated thing to try and say, but you can say, okay, what's the click-through rate increase? That is a really straightforward thing to measure. You can measure time to deployment on your data projects. You can measure how much time that your employees have saved. You can measure how many users are interacting with a product. Those things are easy to measure, and you should be measuring everything, right? This is data science, so can't stop at the modeling. We should be taking data on everything. Okay, so now I'm going to transition to talking about the value from the data teams. And this is the part of the talk that's a little self-serving. I'm a training provider, as you know, so this is something that when we talk to customers, a lot of times they want to know, well, if our employees take your training, what can you do for me? And a lot of times I ask them questions. Well, okay, what are you measuring today? What does your team do today? And sometimes they can answer the questions and sometimes they can't. You know, I would love it if everybody was measuring all of these things all the time because I'm a data scientist and I love data. So how do you measure the value of a team? I mean, the very most basic way is this team is producing data products. So you can measure the value of those data products, right? Just like we talked about before, those projects are producing some sort of ROI, be that in dollar signs, be that in hours saved. Maybe people are interacting with the project. Maybe maybe their project is a dashboard that executives are looking at to help them make decisions, right? And we can calculate value just based on those products. But there are other things to consider when you're looking at a team as a whole. This is not a complete list, but some things to think about. One thing is sustainability and reusability in code development. So when your team put together this dashboard, did they do it in a reusable way, right? There's a big difference between dashing together some really messy code in a Jupyter notebook and kind of getting something that barely works today versus writing really clean modular code where you can reuse pieces of it for other projects, where somebody can easily read it and see what's going on. People can easily edit it, to maintain it, so on and so forth. How good is the code? Technical debt is another piece here, right? If you created a project, but you also created a ton of technical debt while you did it, that's something that you're going to have to pay off later. You know, conversely, maybe your project was a little bit slow, but you resolved a lot of technical debt as you built it. You know, those are all things to kind of weigh in that don't immediately bring value, but are things that are really, really important over the long term. How much technical debt are you creating versus resolving? You know, how sustainable is your code? How much of your code is being reused across projects? That number should be high, probably higher than it is in most places. Maintenance costs of the project is on a similar line. If you are deploying something in Docker, which is sort of the industry gold standard, and you have the environment as lightweight as possible, it will typically be fairly lightweight to maintain. You know, maybe you've built a project that relies really heavily on temperamental external libraries that update all the time, and maybe the code's not very good, and so it doesn't break intelligently, then your maintenance costs will be a lot higher. Right? Your project is not, software projects are never finished, and this is data projects as well. There's always some maintenance costs. How well was the project built? You're still gonna have to do that. Lessons learned from experimentation. Some percentage of these experiments are going to fail. And I think the important things to consider are, one, how much were you measuring and how quickly did you realize the experiment was going to fail? And also, how well was that documented so that you know next year when somebody raises this question, you can actually say, hey, we tried this last year and here's the result we got. It was pretty subpar, right? If you learn lessons and you document things well, hopefully you'll know what to try next time, what not to try next time, and you can have the science to back that up. And then also, how many end users interact with the project? If you build this beautiful dashboard and nobody uses, or maybe you build an ugly dashboard. Maybe it's very informative, but it's ugly, and so nobody interacts with it because they don't really understand it. If it's a beautiful dashboard and the executives interact with it and use it to make decisions, that has intangible value. So how productive is your team as a whole? Here are questions you could be asking. How many data products are they producing? And a lot of these things you'll see in this list are going to be similar to and borrowed from how you would measure the productivity of a software team. There's a lot of overlap here. What's the average time to deployment, right? We're calculating the velocity of how fast people are producing things. How often are you deploying updates? And then what is the variance of the velocity? And so what that means is, what that's really getting at is how good is your team at estimating how long something's going to take them, right? If the variance is low, then they're pretty good at estimations. If the variance is high, they're bad at estimating time, which is not great for planning future work. We should always be striving to get time estimates more accurate. We've hit this one. How many end users for the product? How many decisions are made as a result of those data products? If you can calculate that, that's gold. How many experiments are conducted versus how many are successful? Hopefully, as you continue this experimental mindset and you document things, you'll find that the successful percentage goes up over time. How often are there outages, right? This goes back to kind of maintenance costs. Your product is going to go down at some point. This is the world we live in, but is it built in such a way, and is your team capable of restoring service quickly? And the last one, how much time is my team getting for professional development, learning, and staying on top of new technologies? This one may seem a little counterintuitive, because this definitely does not translate to direct immediate value for the business. But without it, you will likely have a lot of employee turnover, and your employees are a valuable part of your organization. Furthermore, it's going to prevent you guys from stagnating. If they are learning and they are staying on top of new technologies, they will have suggestions for, here's this new technology that solves a problem that we haven't been able to solve for years. We should try it. As you're getting started, questions that you should ask your data professionals. During the business alignment, as you're planning the project, ask them to estimate how many hours it's going to take them to get to the end of the investigation stage. Who are those end users? When can we get them involved? How do we get their feedback throughout this development process? And then what business metrics will we use to measure success? And this one is really important because data scientists, we have model metrics that we use to measure how well models work. Those model metrics, things like sensitivity, specificity, root mean squared error, mean average precision, those things don't always really translate to something that makes sense to the business. So we'll need to align on both what sort of mathematical metrics and what sort of business metrics you should be looking at before you start the project. And then after the project is over, if you're retroing, was it a success? In addition to, did it provide the value that we think it did? These are other questions you should ask. How much of this code is reusable? How much technical debt did we incur in this project? If someone changed the code, who would know? Who would be able to fix it? And what's your post-deployment and maintenance plan for this project? Okay, I think I've actually managed to be almost exactly on time here. So thank you so much for all of your attention, and we will open it up for questions.
I'm coming, Taryn. And whatnot. So I have a couple questions. We do have a little bit of time here. The first one is, how can we get stakeholders more involved in the production and use of data products?
Yeah, that's a great question. So there are a number of workflows that are recommended for working on data science projects. Crisp DM is one that's really popular. There's a number of others. And so what this looks like is this iterative workflow where you have identified stakeholders ahead of time. And so it's in a really cross-functional manner where you design this experiment like so, and this should be based on business priorities. Projects, you should be estimating both the ROI and the difficulty to implement before anybody starts work on them. There's something called a WSJF, weighted shortest job first. So business stakeholders and the data science team should be working together to identify how much value will this bring us, but also how hard is it to do, right? You balance those things out, you find something that has the biggest impact that doesn't take very long to do, or, at least balances those things. And then you start work on that. You have a clearly defined success metric, and okay, 2 weeks in, we're going to want to see this. And then you have cross-functional, like stand-up style meetings where people get together, the data team presents what's going on, the stakeholders ask questions, and then you're not afraid to call it quits, right, if experiments aren't working.
Yes, exactly. Moving on quickly to our next question. If our data teams are not producing projects with value, how can we change that?
Yeah, absolutely. So I think I actually maybe spoiled the answer to that in my last response. You want to do that estimation of value ahead of time, and again, not be afraid to call it. I think one thing that's also really lacking is the deployment and sort of education on the back end. So a model that's deployed that nobody is looking at is not really doing anybody any good. And so some of this is going to also just involve technical literacy training for the rest of the company. Something I see all the time is that people are very reliant on things like spreadsheets. And so if they get information in any manner that's not a spreadsheet, they kind of shut down, like, I don't know what this is, And a data team is generally not going to be producing spreadsheets. They're going to be producing things like dashboards. They could produce something that could be put into a spreadsheet, but they're going to be using databases, dashboards, web applications. And so they need to be producing things that are valuable per the process we just talked about, but we also need buy-in from the rest of the company to be willing to modernize how they receive data results.
I believe we have time for one more. Taryn, if I could throw this in there, which is how do you approach training for busy teams with time and workload constraints that can't be pulled off of projects?
Yep, we get this one all the time. So there are really a number of answers to this. One of which is that at some point you have to commit to training, especially if your team is using technology that's dated. Like we talked about, AI tends to improve things by automating things away. If you're doing everything manually, there is some, you have to hold your breath and do some investment. Our company, we do a number of things that we can keep training to be very part-time. And the other thing is, training does not have to be abstract, right? It does not have to be this thing where you're sitting and you're solving math equations and not doing anything realistic, right? You want to invest in a training that actually uses your data, your use cases, customizes to the kind of problems that you have. And so your employees, even as they're being trained, will be turning their skills back to their job in real time and improving their workflow even as they're going through.
Perfect. Thank you so much